Hello and welcome to World Festival 2021. It is my pleasure to introduce our next speaker. This is Mr. Dario Dallafrate. He is the Product Marketing Manager for GuardSquare. But now be joining on screen. Thank you.
Thank you, Marcus, for your introduction. Today, I'm going to answer the question with my talk, why does a comprehensive approach to mobile app security matter? But before starting, I have to make a confession to all of you. I jailbroke my iPhone. Yes, I did. Last year, my iPhone battery was almost dead, and I wanted to replace it, but I had tons of holidays photos and documents that I didn't want to lose while replacing the battery. So I tried to back up my phone, but unfortunately my cloud storage was full. So I had the great idea of jailbreaking my iPhone in order to download with just one click all my data. I Googled, I found an app for that, and I jailbroke my iPhone and I downloaded all my file. Mission accomplished. The next day, I received the electricity bill, and I wanted to pay the electricity bill as usual with my banking app. So I ran my banking app, but the app crashed. It was strange. So I downloaded a new version, and I ran the app again, and this time I got a nicer message. Sorry, this app is not supported on jailbroken devices. Okay, I'm a bit of an hacker, so I thought, no worries, I can restore my phone and I can remove all jailbreaking traces, so I can use my banking app again. I Googled and I found how to do that, how to restore my iPhone to the initial state. Mission accomplished. I launched the app, the banking app again, and this time I got a nicer message. Sorry, there is an issue with your user authentication. Contact customer service. So I was really in trouble because I was able to download all my data, but but at a huge cost. I was not able anymore to use my banking app, and I was not able anymore to pay my bills. So at the end of the day, I called the customer service. I explained them what I did, and I begged them to restore my banking account. This was my first experience with mobile application security and real-time mobile threat monitoring. Fast forwarding to today, I work for a mobile application security provider, GuardSquare, and now I understand better the huge risk that I exposed myself by jailbreaking my iPhone. Basically, mobile operating systems like Android and iOS have some security mechanism to avoid that, for instance, app X can access data of app Y without user permission. By jailbreaking my phone, I removed those mechanisms. So, for instance, a malicious app downloaded even from a regular store could steal sensitive data saved in my bank app or in another app on my phone, eCommerce app, for instance. What kind of data? For example, credit card credentials, or just my account to access other internet services. You might wonder if these threats are common. Actually, they are. We constantly see in the news a lot of mobile malicious apps used to spread malware. And malware are used to steal confidential data. Recently, almost 6 million of users downloaded a malicious Android apps from the store, and those apps stole Facebook login credential. But there are also very nasty malwares that target financial institutions, financial apps to steal bank account credential. For instance, Alien is one of them, and this malware keeps spreading across mobile platforms. And in Europe, recently emerged another malware called T-bot with the same goal, stealing financial data. And it's very likely to find financial data or bank credential in my phone, in your phone. According to a research done by MasterCard, last year, around 64% of online retail and e-commerce customers tried a new digital payment. But unfortunately, 1 out of 4 customers experienced some kind of online fraud involving mobile devices. And unfortunately, regarding malware, there is even a more sneaky threat associated to this kind of attack. And the threat is credential harvesting to support even darker and more dangerous attacks. Malware, together with other techniques, for instance, phishing, are used by bad actors to create huge database of user credentials. And we see in the news that these databases are sold on the dark web. Are sold to other cyber criminals that can use the credentials inside this database to perform more dangerous attacks. For instance, ransomware. This year we have seen a lot of ransomware spreading worldwide. In US, for instance, the famous case of the Colonial Pipeline ransomware, but also in Europe, recently in Italy, my country, cyber criminals attacked a COVID-19 center IT system in Rome. You might think that this kind of threats affect only Android apps, since Android operating system is an open system compared to iOS. Actually, even iOS is very exposed to mobile threats. Just to make an example of a recent news published by the Washington Post. Washington Post researchers analyzed the apps in the App Store, and they found that within the top 1,000 grossing apps, almost 2% are scams. And of course, there are also malware, as shown in the previous slide. So threats, mobile threats are common, both on iOS and Android platforms. But besides malware, there are other security issues affecting mobile apps. For instance, these security issues are introduced by developers by mistake, or by overlooking security, since they are pressured to meet timelines in order to stay competitive in the market. A new recent analysis of iOS and Android apps released to Apple's and Google's App Store over the past 5 years found that many apps deliberately break HTTPS protections, allowing insecure communication between the app itself and backend systems, servers. This security issue would facilitate, for instance, man-in-the-middle attacks. It means that bad actors could eavesdrop communication between your mobile app and the backend server, for instance. Security researcher found also that almost 1,000 of mobile apps have common data leak vulnerabilities. What does it mean? It means that sitting in their code without any protection, bad actors can find password, API keys, IP addresses, email addresses, or in general sensitive data, very sensitive data. More, and also in the news recently, we read that more than 100 million Android users had personal information exposed by 23 very popular apps, which were misconfigured. And basically, what does it mean? It means that these those apps exposed API keys to access different cloud services where user data was stored, so exposing a lot of user information to the public and also to bad actors, of course. And this is a huge problem, a very huge problem, because the average cost of a data breach is increasing year after year, and this year has risen to more than $4 million on average, the highest average figure in the last 17 years. So you can imagine a data breach could be very, very dangerous for a company. It could mean bankruptcy for a company. Overall, almost 40% of organizations suffered a security incident last year involving mobile devices. And 66% of security incidents had a major impact on the organization. It means basically a financial loss. And the situation is not getting better, not at all. Security incidents are very likely to become more and more frequent, mainly for two reasons. According to a research published by CNBC, by 2025, the vast majority of internet users will access the web mainly from their mobile devices. The use of apps has increased a lot during the last year, maybe also due to the pandemic, because we can go around, so we need to stay at home and playing with our mobile devices. But compared to last year, we spent 40% more average monthly hours on mobile apps. So it's normal. There is no surprise that bad actors are very interested in attacking our apps, our mobile devices. But surprisingly, only 35% of organizations have implemented security best practices, despite 85% saying that it's an important goal for their company and their business strategies. And those who have security best practices in place mainly rely on pen testing. This means that they find security issues only when apps are already released in the market. And so they have a very high, I would say, huge remediation costs, up to 100 times more than the fixing cost during the development. So, how can organization improve their mobile security posture? A better approach is shifting security left, which means implementing comprehensive security strategies, security tools earlier in the development process. There are quite a few benefits of shifting left. The top three are lowering the cost of cyber security, solving issues when the apps are in the development phase is much cheaper than solving issues when apps are released in the market. The second benefit is streamlining application security, making it easier to address issues without distracting developers from their main activity, that is the app development. And at last but not least, shifting security left facilitate the collaboration between development teams and security teams. So let's see the first step of shifting security left. And the first step is integrating security testing earlier in your app development process. I don't mean that you have to replace pen testing. I think that pen testing is still very relevant to check the security of your app when the app is released in the market. With integrating security testing early in your app development process, I mean using tools built for developers and designed for mobile applications to keep checking the security of your apps while your development team is creating the apps. Ideally, those tools integrate easily with the IDEs used by your development team or with your CI workflow. And ideally, these tools don't distract developers from developing the apps. So they show mainly true positives, so real security issues. And at last but not least, these tools provide actionable recommendations to fix faster the security issues. And you know what? We have developed such a tool, and you can use the tool for free. You can do unlimited scans of your Android app, getting actionable recommendation to fix issues in your app code and in the dependencies. The tool is based on a well-known and recognized ProGuard technology, and as ProGuard, it has been created by developers for developers. And at last but not least, it's supported by a community of developers. You can find it going to garsquare.com/appsuite. It's totally free. So after identifying security issues in your mobile apps, you want, of course, to fix them during the development. And the way is implementing mobile application shielding. It means basically using techniques inside your apps to protect them from bad actors' attacks. There are two main types of mobile application shielding approaches. One is code obfuscation and the other one is anti-tampering. And now I'm going to talk about them. According to OWASP, reverse engineering is one of the top 10 threats affecting mobile devices. Bad actors use the compiler tools to decode unprotected apps in order to understand how they work, with the goal to tamper with them, to steal intellectual property, money, or user credentials, as shown in the previous slides. Code obfuscation includes a set of techniques like encryption of your code, removing metadata in your code, renaming classes variable, altering the code structure without altering the function of your app and without altering the user experience of your app, or even removing debug information. And the goal is always the same, to make it harder to reverse engineer your app. According to OWASP, tampering with apps, so it means changing the behavior of your apps while they run, is also one of the top 10 mobile threats affecting Android and iOS applications. Bad actors use tools like debuggers or specific hooking tools like Frida to change the behavior of your app at runtime. So when the app runs on a smartphone or on a virtual environment. To prevent that, runtime application self-protection provides a set of checks that are injected into your app to detect jailbroken or rooted devices, to detect tampering tools, to detect debuggers, or any other tool used to change the behavior of your app while the app is running. I would like to share some examples from different categories of apps, so from different sectors. The first one is the financial services sector. Do you remember my first experience with my mobile app security? I do. I jailbroke my iPhone and I was not able anymore to use my bank app. And I didn't know why. Now you know. I know the reason. The reason was that real-time runtime application self-protection were in place, detecting that I was running the app in an insecure environment, a jailbroken device. A jailbroken device or a rooted phone is insecure because it's easier for bad actors to install tools to tamper with the app. It's easier to install tools to reverse engineering the app. And we have seen why bad actors are willing to do that. They want to steal money. They want to steal user credentials to do other more dangerous attacks. So I was not able to run my app due to runtime application self-protection in places. Another interesting example is in the e-commerce and retail industry. We recently did a review of 250 widely used Android e-commerce apps. And unfortunately, we found that almost 70% of them leak sensitive personal data. For instance, names, usernames, emails, phone numbers, geolocation data, account numbers, serial numbers, and so on. Of course, using a code obfuscation, you can hide names of function and classes that deal with sensitive data. And so you can make it more difficult to understand the app by reverse engineering the app itself. Moreover, you can use encryption to hide strings which have sensitive data, and you can also use runtime application self-protection to protect apps against analysis at runtime. Another interesting example is in the mobile gaming industry. Mobile gaming is booming, and of course, bad actors are moving to this sector as well. We see that mobile game cheats are widely used to unlock premium features or to obtain unfair advantages. For instance, unlimited weapons in a game, or unlimited lives, or unlimited coins to buy additional features. And the bad actors create those cheats by reverse engineering unprotected games, so they understand how the game works, and so they are able to develop tools to tamper with games while they run. And it's also very common that bad actors change the game code, repackaging the game and redistributing games for free on alternative app stores. Obfuscation makes it harder to reverse engineer the game. And while runtime application self-protection prevents bad actors from tampering with the game while it runs. So at this point, you might wonder why not implementing these techniques on your own. The techniques that I have explained so far. Well, there are some unique benefits of using GuardSquare tools instead of do-it-yourself. And I would like to show the three main benefits. The first one is multi-layer protection. Maybe you have seen a medieval castle. Many of them are surrounded by water, like in this picture. They are surrounded by walls. They have turrets and lookup points to check if enemies are coming. And inside the walls, there is the keep. The keep is the main tower used as a last refuge in case of a siege in the ancient time. So basically, in an old castle, there are several layers of protection. We protect your app in the same way, applying several layers of protection to make it harder for bad actors to reverse engineer and tamper with your app. The second benefit is resetting the clock. And maybe if you have my age, you remember a 90s movie with Bill Murray called Groundhog Day. Bill Murray in that movie is a weatherman who goes to a small town for an assignment, and he's shocked because he wakes up the next morning realizing that he lives the same day over and over. when bad actors attack apps protected by us, they feel a bit like Bill Murray in Groundhog Day. Why? Because bad actors need to restart the attack over and over. Because anytime you release a new update of your app with our protections, automatically a new set of multi-layer protections are applied. So bad actors have to restart the attack from the beginning, from scratch. At last but not least, another important benefit is a uniform approach. Nowadays, apps need to run on different platforms, Android and iOS, for instance. They are coded with a lot of different languages. We have native apps programmed with C++, for instance. We have hybrid apps. And so to reduce time and effort, it's important not to reinvent the wheel every time. With the Gasquet solution, developers can use a uniform approach to in-app security protection. So, regarding comprehensive approach for mobile application security, at last but not least, it's really important to talk about real-time mobile threat monitoring. With real-time mobile threat monitoring, you can keep real-time visibility into the threat-led escape when applications are published. Basically, to achieve that, it's important to monitor threats in real time with intuitive dashboards and with alerts, custom alerts also. It's important to keep analyzing threat data in order to uncover how threat actors are attempting to compromise your app. And at last but not least, it's important to act on this information using insights, for instance, to identify suspicious users and to implement security findings into future upgrades of your app or future development of your app. And I would like to share an example as well. And do you remember my first experience with mobile app security? I do. I jailbroke my iPhone and I was not able to use my bank app anymore. Even after restoring my iPhone, removing all jailbreaking traces. And even doing that, I was not able to use my mobile banking account anymore. And at the time, I was very, very upset. But now I have to say that I'm very happy that my bank did that, because it means that my bank has a comprehensive mobile application protection strategy in places. They use mobile application shielding techniques like runtime application self-protection to detect that I was running the app in an insecure environment. But they use also real-time threat monitoring tools to keep visibility on security of their app in the market. Basically, what happened after jailbreaking my phone and after trying to use the mobile app, I was flagged by their system as a suspicious user. So I was banned and I couldn't use the service anymore. I could access the service only after begging them to restore my account. So during this talk, you have seen quite a lot of information. You have seen the most frequent mobile threats, malware, security issues, apps leaking sensitive data, and so on. You have seen how frequent these threats are and what their impact is on organizations in different sectors. Then I have shown you the benefits of a comprehensive mobile application protection security, shifting security left. So it means addressing mobile application security earlier in the development process. And I've shown you the three main steps to do that, using mobile application security testing, then fixing security issues with mobile application shielding, and at last but not least, keeping monitoring apps when your Android and iOS apps, when they are released in the market. Please visit our website if you are interested in getting more information.